So section 3.5 should be a friendly section. This is a rework of my original section 3.5, which had 4 videos that were about an hour and 15 minutes each. I spent a ton of time with the original videos doing theory and showing how to do the problems, and I think I spent so much time doing theory that students missed what they really needed to get out of it. So I'm stripping a lot of the theory out of this and just going to show you how to do the problems. It should be a pretty friendly section. I don't know if I could do it in an hour, but I'm going to try. So for each of the first 56 problems, I'm going to use one of the 4 functions that are given to me. And I just made these. They're just standard functions: an x squared parabola, a square root function, an absolute value function, a cube root, and a cube function. So I just made up some generic functions, and for each of the problems between 1 and 56, it's going to call out one of the 5 functions, but not all 5 of them. And we're going to be asked to do 2 things. We're going to be asked to create a function that's related to the given function, but has some modification. And we're going to be asked to describe how the graph of the original function relates to the graph of the function I created in part A. And let me just show you how to do it without doing too much theory. So question 2 calls out the function, the absolute value of x, which when I do a graph of this on my calculator in a second to help explain some of the theory, you'll see it's just a graph of a v. Part A wants me to create a function by changing the x to an x plus 4. This function notation that has an x plus 4 in a parentheses, that tells me anywhere in the h function on the right hand side where there's an x, I need to change that to an x plus 4. So that's all I'm going to do. I'm going to change the x that's in the h function on the right hand side to an x plus 4. That's my answer to part A, the find each function. Part B wants me to describe how the graph of the answer in part A relates to the graph of the answer of the function in the original function. And to do this, I'm going to show you on my calculator how the graphs relate. I'm going to explain it, or I'll show you it visually, and then I'll show you a shortcut to get it. So I'm going to graph this function, the absolute value of x. I hit my y equals button. The absolute value on my version of the 84, I have to hit the math button, arrow over to NUM, and ABS is for absolute value. So the absolute value of x, if I just graph that function with a nice standard -10 to 10 window, it's just a generic v. In a minute, I'm going to graph the function, the absolute value of x plus 4, in my y2. And what it's going to do, it's going to give me a graph. And I have to describe how that graph relates to the graph of the function that with just an x as opposed to an x plus 4. To do that, I move down to my y2, I hit my math button, I go over to NUM, I hit enter on absolute value, I type in x plus 4, close out my parentheses. Now when I hit a graph, it's going to graph the function, the absolute value of x plus 4. If you look at the 2 graphs next to each other and you count it over, you could see that the second graph that I drew, which is my answer to part A, it's the exact copy of the initial graph. It's exactly the same dimensions, the same width of the v. It's just moved 4 to the left. So I'm going to say, to describe the transformation, I'm going to say it's moved, or I'm going to say it's shifted. Moved might be a better word, but shifting is a common word for this. 4 units to the left. It's exactly the same graph. The width of the v is exactly the same. It's just slid over. That's everything there is to do for part B. There isn't really any algebra to do. I'm going to move on to do question 4. Maybe you can sneak and try to do question 1. But as I do question 4, it's calling out the same h function. So in question 4, when I go to do it, I'm going to use the same h function, which is the absolute value of x. In part A, I'm going to find the function, the h of x plus 3. What I need to do to find h of x plus 3 is to change any x in the original function to x plus 3, and I'll just do that. That's the answer to part A. That's the find each function. For part B, I'm going to describe how the graph of the absolute value of x compares to the absolute value of x plus 3. The absolute value of x has a graph that looks like that. In a second, I'm going to graph on my calculator the absolute value of x plus 3. And because I know the trick, what I'm going to get is a graph that's exactly the same as the absolute value of x, except it's going to be shifted 3 units to the left. In fact, anytime you create a function by changing the x to x plus a number, what it's going to do to the graph is going to just take the graph and shift it to the left. And let me just show you that real quickly. So in y1, I have my absolute value of x. In y2, I have my absolute value of x plus 3. When I sketch a graph, there's the absolute value of x. And now the graph has moved 3 units over, 1, 2, 3 units over. And so my answer to part B, the graph is going to be shifted or moved to the left 3, and I'll maybe stop writing units just to save some time. So you should be able to do question 3, and I'll move on to do question 6. Question 6 and question 5 is calling out the x squared, which is a parabola function. And the part A is a little bit trickier because the function itself doesn't have something that's working like a parentheses. The absolute value, although it's not a parentheses, it kind of works like a parentheses. When I go to do question 6, it's calling out the f function, which is my x squared function. 6a wants me to find the function f of x plus 3, which means I need to change that x to an x plus 3. In the last few problems, I didn't take the time. Whoops, 6 is absolute value of x plus 1. I'm sorry. In the last few problems, I didn't need to put a parentheses when I did this change because the absolute value worked like a parentheses. For the x squared and the x cubed function, when you're asked to find f of x plus some number, if that plus some number is in a parentheses, when you create the answer to part A, you need to introduce that parentheses. It would be wrong to write this without a parentheses because the squared applies to both the x and the 1. I'll go ahead and predict my answer to part B, and I'll show you on my calculator the best I can how the graphs relate. I really want to put down 3. I don't know why. The first, when I go to do this on my calculator, x squared is just a generic parabola. It looks something like that. And then on my calculator, when I ask it to graph the absolute value of x plus 1, what it's going to do, it's going to draw an exact copy of the original graph. It's just going to take it and shift it 1 unit to the left. Because when you add a number inside a parentheses using function notation, the graph that you create by the second function is related to the original function, but it's just moved to the left. So if I go y equals and clear out the functions I had in there, put the x squared function in y1, and my answer to part A of number 6 in y2, it'll graph the parabola, vertex at the origin, and that's going to take the whole parabola and shift it 1 unit to the left. I have a little cheat sheet for this section that I usually show about now, so let me bring that cheat sheet out. So in order to get my answers to the part B's, if I understand this cheat sheet, I can get the answer without sketching graphs, and eventually I'm not going to sketch graphs because it takes too long to do. So these problems that I've just been doing uses this line or this portion of the table. It says if I'm finding a function, it doesn't matter what the name of the function is, but if there's an x plus some number in a parentheses, and that's a positive number, I don't want plus a negative inside the parentheses, but if I have x plus a number in a parentheses, the function that I create is going to have exact same shape as the original function. It's just going to be shifted to the left, whatever the number is in the parentheses. And so I really don't have to graph these to get the answer to part B if I understand everything on this sheet, and eventually you'll understand everything on this sheet. So for question 7 and 8, it's calling out the f function again. So question 8 is calling out the f of x function, the nice parabola, which is the x squared. 8a wants me to create the function f of x plus 4. I'm just going to change that x to an x plus 4, and I need a grouping symbol to make the square apply to the whole x plus 4 and not just the x or just the 4. That's the answer to part A. And part B, the graph is going to be the same when I graph x squared and x plus 4 squared. The x plus 4 squared is just going to be shifted to the left 4 units. So if on my calculator I change the y2 to the answer to part A, so if I had the original function f of x in my y1, the answer for 8a, x plus 4 squared, and y2, there's the initial graph. The second graph is going to be 4 units shifted to the left. So when you're adding a number inside of parentheses, the graph between the original function and the newly created function are the same. The second one will be the original shifted 4 to the left. The next few problems are going to be shifting to the right. The next few problems, 9, 10, 11, and 12 on this sheet, the problem itself has f of x minus a number, and that number is a positive number. I don't have a double negative here. And how this is going to impact a graph, the graph of my part A is going to relate to the original graph, but it's going to be shifted to the right, the number after the minus sign. So question 10 calls out the h function again, which is just a generic absolute value. Question 10a wants me to create the function h of x minus 4, and I do that by changing that x to an x minus 4. I don't need a parentheses because the absolute value is kind of working like a parentheses. 10b wants me to describe how the graph of the absolute value of x minus 4 compares to the absolute value of x. And from my table, because I've written this table, I know how it works. This graph is going to be that graph shifted to the right 4 units. So I'm going to say it's going to shift to the right 4 units. And when I go to do this on my calculator, just to show you, the absolute value of x is just a v kind of centered at the origin. The absolute value of x minus 4 is going to be that same v, but shifted to the right 4 units, because putting a minus inside a parentheses in function notation, what it does is it takes a graph and it bumps it over 4 units. So let me just go ahead and graph these real quickly, hitting in y1 math num absolute value of x, which would be this generic v. In y2, do math number absolute value of x minus 4. That's the right side of my answer to 10a. When I hit graph, it's going to do the exact same graph as in 10 as the absolute value, just shifted 4 to the right. These are called rigid transformations. When it takes the graph and it doesn't distort it, it doesn't make it narrower or wider, it just lifts it up and moves it to another place. For number 12, it's calling out the h function again. For 12a, I'm supposed to find the function h of x minus 3. Because the minus is in a parentheses with the x, I'm just going to change that x to x minus 3. I don't need a parentheses when I do this because the absolute value is working like a parentheses. And I don't need to sketch a graph to know how these graphs relate to each other. If inside a parentheses, I create using function notation with x minus a number, it's going to take the graph and shift it to the right that many units. And to save a minute, I won't sketch a graph. The next 4 problems call out the g function, which is the square root of x function. For what it's worth, a square root of x is a half parabola on its side. When I go to create the function in problem 14, I'm not going to need a parentheses for the part A's. The reason I'm not going to need a parentheses is because the square root symbol is kind of working like a parentheses. The absolute value, the square root, and the cube root symbol, when you're doing the g of x or the f of x plus or minus a number inside the parentheses, the absolute value, the square root, and the cube root symbol kind of work as the parentheses, so I'm not going to use a parentheses for those. So this is the find each function, and in 14b to describe how this graph relates to that graph, because in function notation, if there's a minus inside a parentheses, it's going to take the graph and shift it to the right that many units. If I keep showing the graphs, it's going to take infinitely longer, and I don't think we need to do that. So I'm not going to do that many graphs until it's a new concept. For 16, it's calling out the g function again, which is the square root of x. Part A wants me to create the function g of x minus 7. I do that by changing the x to an x minus 7. I don't need a parentheses here because the square root symbol is working like a parentheses. That's the find each function. And for part B, the graph is going to be shifted to the right 7 units. Notice I'm going to probably progressively get lazier. I might stop using the word shift. Sometimes instead of writing the word right, I might do that, an arrow pointing to the right with the number that it's shifting. We get lazier and lazier. If you looked at my keys on a test for a problem like this, I would probably do something like this, or I might do R7, but I probably wouldn't write this whole, shifting to the right. The shifting, I think, is implied. Something new. 17, 18, 19, and 20. You'll notice it has a plus, but it's a different kind of a plus. The first few problems that we did with the plus was inside the parentheses, so that plus one either inside the absolute value, under the square root, or inside a parentheses with an x. In these problems, it doesn't matter what the function is. The number, because it's not in a parentheses, is just going to be dumped after the function. It's not going to be inside a parentheses ever for these. So for problem 18, it's calling out the f function, which is just a generic parabola, and x squared is just a parabola that looks something like that. 18a wants me to create a function, and the big difference between this and this is where the plus is. If the plus is inside the parentheses, this would be the appropriate thing to do for an answer, but it's not. The plus is after the function. It's just now going to go after the function in my answer. So I'm going to, whatever function's given to me, I'm going to write that function down and put the plus 3 afterwards. For part B, I'm going to interpret my template, then I'll graph these. This is the top row of my template. If you have a plus and it's after but not in the parentheses, it's after the function name but not in the parentheses, and you're adding a positive number, it's going to move the graph up that many units. So let me do more of a complete sentence here. So I'm going to say it's going to shift up 3 units. And when I go to graph this on my calculator, this vertex, which is at the origin, is going to be moved up 3 units. I'm going to get a parabola that looks something like this. And let me show you that real quickly here, just to illustrate the answer to part B. The original function in 18 was x squared, which is just a generic parabola. When I go to do part B, this parabola is going to be moved up, so its vertex is at the point 0, 3. So when I go to do part B and do x squared plus 3, no parentheses needed when the plus is after the function and not inside the parentheses, it's going to graph a function, same exact function. If you just took the function and drug it up 3, it fit in perfectly. For 20, it's calling out the g of x function, which is the square root function. For part A, it's asking me to find g of x plus 6. Because that plus 6 isn't in a parentheses, the plus 6 doesn't go under the square root, it goes after the function. So these, we're going to get the original function back, and the plus is going to go after the original function. The answer to part A is just the original function plus 6. For part B, a plus, not in a parentheses, moves the graph up that many units. Let me show you this. Basically, the square root of x is a graph that is a half parabola on its side. The graph that I'm going to get when I do the square root of x plus 6 is going to be 6 units higher. So if I did in y1, the square root of in y1, the square root of x, and in y2, the square root of x, close out the parentheses to make it so that plus 6 is not under the square root. It's going to give me, there's the square root of x, and then up 6 units is the square root of x plus 6. It just took the whole graph and moved it up. So inside a parentheses is left and right, not inside a parentheses after a function plus is up, and we're going to learn in a second that minus is down. So for 21 and 22, it calls out the h function. So if I'm doing 22, I'm going to need the h function, which is the absolute value of x. Part A, because the number's not in a parentheses, that minus 4 is after the function, so it doesn't go inside the absolute value. When I go to create the function, it just goes afterwards. And to describe, minuses after the function, not in the parentheses, will move the graph down. So this graph is going to be the same, but it's going to be shifted down 4 units. And again, if I wanted to just illustrate this, the absolute value of x has a graph that looks like that. And the absolute value of x minus 4, with the minus not in a parentheses, is going to be the exact same graph, but it's going to be moved down. If it was inside the parentheses, if it was this absolute value of x minus 4 like that, that would move the graph to the right. That's not what's asked here, but that's how all those things relate. Minuses inside the parentheses move the graph right. Minuses after the function move it down. And let me just show you these real quickly just so you can kind of see it. So math number absolute value of x and math number absolute value of x, close the parentheses so that minus 4 is not under the absolute value, and then minus the 4. It'll graph the initial absolute value and then move the whole graph down 4 units for the absolute value of x minus 4. 24 calls out the k function. The k function is the cube root. That function is really not very illustrative for graph purposes. It's harder to see. It's a more complex graph, but I can find the functions and describe how the graphs compare without even seeing the graphs. Part A wants me to find the function. Because the minus 9 is not inside the parentheses, it doesn't go under the cube root symbol. It goes after the function. And minuses inside parentheses move the graph to the right. Minuses after the function move the graph down 9 units. Now we're going to do some combo problems that do left, right, or up and down. A left-right move and an up-down move together. 26 calls out the h function. The h function is the absolute value of x. And it wants me to create a function in part A that has the x changed to x plus 4, and it has 3 added. So it has 2 things. It wants me to change that x to an x plus 4, and then it wants me to add 3 after the function. To change that x to an x plus 4, I just put the plus 4 inside the absolute values, and then the plus 3 will go afterwards. If this was the x squared, I'd need a parentheses for that, but the absolute value is working like a parentheses. To describe how the graph of this compares to the graph of that, the graph of the absolute value of x is just a generic v. This graph, the plus 4 inside the parentheses would move the graph 4 to the left. The plus 3, because plus inside the parentheses moves the graph left, the plus 3 afterwards is going to move the graph up. So when I go to graph this on my calculator, I'm going to get the exact same v that the original graphs like, but it's going to be moved left to the 4 for the plus 4 inside the parentheses and plus 3 for the plus 3 that's after the function notation. So to describe how the graph compares, I'm going to say it's shifted left 4 and up 3. Let me show you these so you can kind of see this visually. So I already have the absolute value of x in. I'm going to change this to the math number absolute value x plus 4 in a parentheses. That makes the plus 4 under the absolute value, and then plus 3 that's not under the absolute value. And when I go to graph this, there's my initial v, and this one's going to be left 4 and up 3. This v, if you moved it left 4 and up 3, they have the exact same width. They'll fit perfectly in with each other. For question 28, it's calling out the h function again, which is just a generic absolute value function. For part A, I'm asked to create the function absolute value of x plus 3 minus 5. I need to change the x to x plus 3. The x plus 3 is going to be under the absolute value function because the plus 3 is in the parentheses. The minus 5 is going to go after the function because it's not in the parentheses. And using function notation, plus inside the parentheses moves the graph left, minus after the function moves the graph down. So for part B, I'm going to say the graph is going to be shifted to the left 3 and down 5. And I'm not going to graph that just to save some time. For 30, it's calling out the g function, which is the square root of x function. In part A, it asks me to create the function g of x minus 4 plus 3. To do that, I need to change that x to an x minus 4. I don't need a parentheses because the square root symbol is working like a parentheses, and the plus 3 needs to be added after the fact. For part B, minus is inside a parentheses, move the graph to the right, so that's going to move the graph to the right 4. Plus is after the function, move the graph up. So this graph is going to be moved right 4 and up 3. If I did this on my calculator, the square root of x looks something like that. And on my calculator, if I was about to graph it, it would take the graph and move it 1, 2, 3, 4 to the right, and 1, 2, 3 up. It's going to look something like that, I guess. And let me just show you that's how that's going to work. So if I took the original function that was given to me, which is the second square root of x, put that in y1, and in y2 do second square root of x minus 4 in a parentheses to make the minus 4 under the radical, and plus 3. That minus 4 part under the radical moves it right, the plus 3 moves it up. There's the initial square root of x, and there's the graph moved over 4 and up 3. 32 is calling out this same g function. In part A, it wants me to find g of x minus 3 minus 5. That means I need to change the square root of x to the square root of x minus 3. The x minus 3 goes under the square root because it's in the parentheses. The minus 5 goes after because it's not in the parentheses. And a part B, to describe how the graph moves, minus inside the parentheses moves to the right. So this minus right there is going to move the graph to the right 3. And the minus after the function, not in the parentheses, moves the graph down. And see, I'm getting progressively lazier in what I'm writing because I think it's understood. And you don't have to be very verbose when you're writing your answers to the part B's. The next 4 problems involve flipping a graph upside down over the x-axis. If there's a negative in front of the function notation, when you find the function, that negative is just going to go in front of the function. And how it's going to impact the graph is going to flip it over or reflect it over the x-axis. So if I was doing problem 34, it uses the g function, which is the square root of x, and it asks me to take the function and multiply it by -1. Because that negative is not in a parentheses, it doesn't go under the absolute value symbol. If the negative was inside the parentheses, it'd go inside the absolute value symbol. Because it's written in front of the function, when I go to find the function, it's just going to be written in front. And for part B, negatives in front of function notations flip the graph over the x-axis. So I'm going to say it reflects it over the x-axis. And so again, the initial graph of square root of x looks something like that. And flipping it over the x-axis, this would be the x-axis, the flip over is going to look something like that. The negative square root of x is going to be the graph just flipped over using the x-axis as a mirror. And just to show you how that looks real quickly, I have the square root of x in my y1 conveniently, and if I do negative second square root of x, That's going to be this graph. It's the same graph. There's the square root of x. Now the graph is going to be flipped over the x-axis. That's the negative square root of x. Again, I don't need to graph any of these to know what the graph is going to, how they compare to each other if I understand this sheet. For 36, it's calling out the function f of x, which is x squared. 36a wants me to find negative f of x. Because the negative's not inside the parentheses, I just put it in front of the function. And when I go to do part B, negatives in front of function notation, we flip the graph over the x-axis. If I was graphing this on my calculator, x squared has a graph that looks like that, and negative x squared looks something like that. It's the same graph but just flipped over the x-axis. So let me show you real quickly. If in my y1 I put x squared, and in my y2 if I put negative x squared, you don't have to graph any of these, but you can just to kind of verify yourself. There's the x squared, here's the negative x squared flipped over the x-axis. Exactly the same width of the parabola, it just flipped over. The next problems, instead of having the negative in front of the function, they have the negative inside the parentheses. Negative inside the parentheses is going to flip the graph over the y-axis as opposed to over the x-axis. So in problem 38, it's calling out the g function. Unlike the last few problems, the negative sign is inside the parentheses. If the negative's inside the parentheses when you're finding the function, it needs to go under the absolute value sign, or inside of parentheses that you create. It can't just go in front of the function. So this is supposed to say negative square root of x. And what that will do, if this is a graph of the square root of x, the graph of the negative square root of x is going to take the graph and flip it over the y-axis. So for my part B, it reflects over the y-axis. And let me show you that real quickly. So if I go to my y equals, and in y1 do the square root of x, and in y2 do second square root of negative x, putting the negative in a parentheses to make it like it's under the absolute value as opposed to in front of the absolute value. Here is the square root of x, and this is going to be the square root of negative x flipped over the y-axis. 40 calls out the function x squared. Part A wants me to find f of negative x. Because it's in a parentheses, I need to put that in a parentheses because the x squared doesn't have something that works as a parentheses. That's the find each function. This is actually the same as x squared because if you square a negative, it just gets positive. So both of these would be correct answers for part A. And for 40b, it's going to reflect over the y-axis because negatives inside parentheses reflect graphs over the y-axis. Negative in front of the function reflects it over the x-axis. I usually don't ask y-axes on the test, but I usually do ask x-axes. I have a few more combination problems. So 42 calls out the f function. The f function is the x squared function. And it wants me to find negative f of x plus 4 plus 3 for part A. For the x plus 4 part, I would need an x plus 4 inside a parentheses with an exponent of 2. The plus 3 part would come afterwards, and the negative would just go in front of the x squared. If it was just x squared, it's going to go in front of the x plus 4 since it's an x plus 4 quantity squared. Ugh. So I did the x plus 4 in a parentheses because it's inside a parentheses, and the squared doesn't have something that works as a parentheses. Plus 3 afterwards. The negative only attaches to the x plus 4 part because the plus 3 is free from it. Graphically, what's going to happen, I don't know if I could do this so well, that's the generic x squared. It's going to be moved, if I do part B, it's going to be moved left 4 for the plus 4 inside the parentheses. It's going to move up 3 for the plus 3 after the function. And it's going to be reflected over the x-axis for the minus in front. So there's 3 things that are going to happen, and the reflecting over the x-axis will just have the impact of flipping it over. So it turns it upside down. If you just said it turns it upside down, that would be fine. So I think this is what the graph is going to look like. It's going to go left 4, up 3, and the reflecting over the x-axis just flips it over. Or it could reflect it over the x-axis and then move it left 4 and up 3. That probably would have been better if I said first I move it over the x-axis, then I shift it left 4, and then I move it up 3. It would kind of be the better way to say that. Let me show you these on my calculator. So I'm in y1, I'm going to put x squared, and then negative x plus 4 squared in a parentheses and plus 3. The initial graph's just a generic parabola, and then the graph that is over 4, up 3, and flipped over. If you count it over here, that's actually 1, 2, 3, 4 over, and 1, 2, 3 up, and flipped over. For question 44, it calls out the same f function, which is convenient. For 44a, I'm supposed to create the function negative f of x plus 3 minus 5. The x plus 3 is going to be in a parentheses with the square because the square doesn't have, the x squared doesn't have something that works as a parentheses. The minus will go in front of it. It can't go under the parentheses because it's in front of the function, and the minus 5 goes after because it's written after the function. For part B, the minus in front reflects it over the x-axis. You can write these in any order. The plus 3 inside the parentheses moves it left 3. And the minus 5 after the function moves it down 5. I'm not going to graph this on my calculator, but if I did, it would be flipped over, moved left 3 and down 5. It would be like down here somewhere, I guess. Flipped over, left 3, down 5. If that's 5 units, it would look something like that. But I don't need to graph it to know what the graph would look like. Finally, using the m function. 46 wants me to use the m function. The m function is an x cubed. It doesn't have something that works like a parenthesis, so when I do the x minus 4 inside the parentheses, I need to introduce a parentheses. For part A, the creating the function, the x minus 4 in the parentheses would give me an x minus 4 cubed. The minus in front of the function would go in front of this parentheses, and then the plus 3. I like writing the function notation and then the problem, but I forgot to write that, so be it. For part B, negatives in front of function notation reflected over the x-axis. Minuses inside parentheses move the graph right. And pluses outside after the function moves the graph up. 48 calls out the same function. 48a wants me to find the function negative m of x minus 3 minus 5. To do that, I'll write a negative sign. I need an x minus 3 inside a parentheses with the cube out front, and the minus 5 goes afterwards. For the part B, it reflects it over the x-axis. The minus inside the parentheses moves it right. The minus after the function moves it down. I'm getting worn out, but this is not that gruelingly long like the last go about of this. The next 8 problems I generally don't put on a test. These are called non-rigid transformations. They're going to take the graph, the initial graph, and they're going to distort it. For each one of these problems, 49 through 52, and then when I get on the next sheet, 53 through 56, to create the function, I'm just going to put this number in front of the function notation and not in the parentheses, because the number's not inside the parentheses. So just like the negative sign for the reflecting over the x-axis, it's going to just be written in front of the function. So 50 is calling out the function x squared. Part A wants me to find the function 4 times f of x, and to do that I just multiply the function by 4. And what this is going to do is it's going to multiply each of the y's by 4, and it's going to stretch the function. It's actually going to make it narrower. So I'm just going to worry about these now, and we're not going to worry about this. I never ask these. What happens to a parabola when you multiply by a number bigger than 1 is it makes it narrower. So in part B, I could either say it makes it narrower, because that's really what it does to a parabola. But if it's not something that's like an absolute value or a parabola that could be narrower or wider, the better thing to say is that it stretches the function. What it does is it's going to multiply each of the y's by 4, and that kind of elongates the function. And so I'm not going to say it stretches by a factor of 4, but I might be right to say that. To show you what this does to a parabola, if you multiply by a number that's bigger than 1, it's going to make every y narrower, or it's going to make every y bigger, which makes the graph narrower. And that's what we say, that takes the function and stretches it up. So let me graph this. There's the initial function, and there's the 4x squared. So it got narrower. Basically, each of the y's was multiplied by 4. If I looked at the table, which I haven't done a lot of looking at tables, if you look at the y's in the first one are the y in this column are the y's from x squared, and here's the same y for the 4x squared, and each of the y's are a multiple of 4 apart. If you look at this y compared to that y, they're times 4. This y compared to that y, they're times 4. That's not on the test. So multiplying by a number bigger than 4, it's bigger than 1, that's positive, it's proper to say that it stretches the function. In question 52, instead of multiplying by positive 4, I multiply by negative 4. For part A of 52, it wants me to find negative 4 times f of x. To find each function, I'm going to do the same thing. Because that negative 4 is not inside the absolute value, it's just going to be multiplied by the function. To describe what it does, it's certainly going to make it narrower. It's going to stretch the function. It's going to multiply each y to make it bigger, but this negative is going to flip it over the x-axis. A negative number is going to reflect it over the x-axis. It's going to make it go upside down. I guess I just did. Yeah, that's mine. So it reflects it over the x-axis, and it makes it narrower, or we can say it stretches it. Stretches it is a better word than making it narrower, because if the shape isn't a parabola, that, like a square, if it's like a square root that can't get narrower, it's better to say stretches. But again, I don't test on these. But multiplying by a number bigger than 1 is going to make a parabola narrower. It's proper to say we stretch the parabola. If it's a positive number, that parabola is going to be the same right side up. If you're multiplying by a negative number, it flips it over the x-axis. So if I graph this, this is x squared. This is negative 4x squared. It got narrower because the number I multiplied was bigger than 1. It got flipped over because it was a negative number. 2 more, then we get to a different kind of problem, which I don't like, but you might not mind. So 54, I'm using the absolute value function, and I'm multiplying by a number that's not inside the parentheses. When I go to find each function, I just take that number and write it in front of the function that's given. Multiplying by a number that's bigger, or in between 0 and 1, it's going to make the function wider. The appropriate thing to say is it compresses the function. And multiplying an absolute value, which is a v function, by 1/3, it's going to take all the y's and make them smaller. And what's going to have the impact of is making the graph fatter in some sense, or wider. So if I graphed math absolute value of x and then parentheses 1/3 to make sure the 1/3 is thought of as a fraction, and then math absolute value of x. If I graph these two, the first one's just a generic absolute value of x, and then each of the y's is going to be made smaller. It's going to compress or push the graph closer to the x-axis. And you could say it makes it wider. That would be fine too. So there's the initial, and there's the compression of it, or making it wider. For 56, it's calling out the same function. Part A wants me to find negative 1/3 of x, h of x. So I'm just going to put that negative 1/3 in front of the absolute value. To describe what it does, the negative reflects it over the x-axis. And the 1/3, because it's a number between 0 and 1, makes it wider, and we usually say it compresses. So if we're multiplying by a number, if the number is bigger than 1, we say it stretches. If the number is in between 0 and 1, we say it compresses. And if it's a negative number, we say, in addition to stretching or compressing, we say it reflects over the x-axis. Won't graph that. Done with my calculator. My calculator can do me no more good for the rest of the problems. The rest of the problems, of which I think we'll maybe just go up to 64 and stop. I don't test on these. So let's just do a handful of these problems. So what I'm given in problems 57 through 64 is a graph, and this graph I call f of x. So this graph that's given to me is a graph of some function f of x. It's an absolute value function, definitely, because it's a v. Question 58 wants me to sketch a graph. I don't need to know the equation. I need to sketch a graph of f of x minus 4. I'm not going to find it because I don't know what this equation is, but I do know how the graph's going to relate, because minuses inside of parentheses are going to move a graph to the right. As a matter of fact, all I'm going to do is I'm going to move each point 4 to the right, because the graph of f of x minus 4 is the same as the graph of f of x. It's just moved 4 to the right. So I'm going to take every single point that's given to me and move it 4 to the right. So I'm going to go 1, 2, 3, 4 to the right with that point, make a dot. Take this point, go 1, 2, 3, 4 to the right, make a dot. Take this point, go 1, 2, 3, 4 to the right. This point, 1, 2, 3, 4 to the right, and then 1, 2, 3, 4 to the right. And I'm just going to draw the same shape, which is a V, absolute value graph, best I can. That would be a perfect answer for problem 58. I sketched a graph of f of x minus 4. I knew that the graph of f of x minus 4, since the minus was in the parentheses, was going to be the same graph as the graph that was given. It's just everything was going to be moved to the right 4. For problems 59 and 60, I'm using the same graph, but I'm not moving it to the left or right. I don't know what the equation of this is, but I know if I'm finding the graph of f of x plus 1, I need to take every point and move it up 1 unit. So to create the graph of f of x plus 1, I need to take every point that's given and move it up 1 unit. So this point I'm going to move up 1, move up 1, move up 1, move up 1, move up 1. I took all the points that were given, I moved them up 1, and I'm trying to draw the best I can, something that is a V. That little wobble in there was just my inability to draw straight lines. 62, if I'm going to graph f of x plus 1 minus 2, the plus 1 inside the parentheses is going to cause me to take every point and move it left 1. The minus 2 after the function is going to cause me to take every point and move it down 2. So if I want to sketch a graph of f of x plus 1 minus 2, given this graph called f of x, I need to take every point, move it left 1 and down 2. So first point, move it left 1, whoops, first point, move it left 1, down 2, and then left 1, down 2, left 1, down 2, left 1, down 2, left 1, down 2. best I can now. I'm going to because it looks like that. Left one, down two, left one, down two, left one, down two, left. Yeah, I did it correctly. It just feels, I didn't think it was going to look like that, but I'll live with it. Last two problems are the trickier, reflecting over the axes. I'll do them both in different colors. Let me do 63 for you. 63, negatives written in front of function notation reflect the graph over the x-axis. And so for this one, I need to reflect the graph over the x-axis. And the tricky thing to do this is I need to change the sign of each y to get this graph flipped over. Reflecting over the x-axis makes the graph go upside down. I'm going to take each of the points and change its y. So this point right here, the point -4, 2, I'm going to drop the point -4, -2. I'm going to change the sign of the y, and changing the sign over the y moves the point to the opposite side of the x-axis, and that's how I reflect about the x-axis. This point's the point -2, 0. Changing the sign of 0, which is the y, since the y doesn't have a sign, it's neutral, it's just going to stay there. The point 2, -4 is going to go to the point 1, 2, 3, 4, 2, 4. I'm just changing the signs of the y's. The point 6, 0, again, that's a neutral point in some sense. And the point 8, 2 is going to go to 8, -2. Now I'm going to connect all these points that I just drew. I'm going to get a graph that's flipped over. That's reflecting it over the x-axis. So if you're given something that asks you to reflect over the x-axis, that's a negative in front of the function notation, you change the sign of each y. 64 I'm not going to do, but it's a reflection about the y-axis because the negative's inside the parentheses. And to do a reflection over the y-axis, I need to change the sign of each x. So if I went to each point and I changed the sign of each x, I made that the point -2, -4, so it would go over here on the opposite side of the y-axis. That 6, 0 would go to -6, 0. This -2, 0 would go to 2, 0. If I change the sign of every y, that would give me the reflection over the y-axis. I have a harder time seeing reflections over the y-axis, so I'm going to punt on that one. And let's just stop there. I don't test on these picture graphs. There is one more group of problems that you're more than welcome to try to do, 65 through 72. But why don't you just stop at 64? I think that will be more than enough. All right, so we'll call it quits, and hopefully this 1 hour version of this section was better than what I had been doing.